fascinating. We are going to move on to the second presenter, which is Benjamin Loy from Smartling. So please welcome Benjamin Loy, principal engineer at Smartling, and the kind of person that makes the complex world of localization engineering look deceptively simple. We're going to hold you to that this morning, Benjamin. With over a decade at Smartling, Benjamin has helped architect some of the most robust and scalable systems in the industry, always with an eye towards automation, integration, and elegant solutions. In his talk, entitled Engineering with Non-Deterministic AI Behaviors, he will demonstrate one of the thorniest challenges facing AI engineers today, how to make outputs from large language models more predictable and reliable. Go ahead, Benjamin. That's a whole big task. We're looking forward to seeing that happen this morning.
All right, I'll see what I can do in 20 minutes. Thanks, everybody. I'm Ben. I'm from Smartling, Engineering of Non-Determinate AI Behaviors. So I'm going to start with the opportunity of just stuff on the ground that I've been seeing over the last few years that I'm sure tons of people on this call have also seen. One of my first observations is impossible to tell if a prompt's going to work by only reading it, right? I've seen things in prod with spelling mistakes and logic errors work totally fine. I've seen detailed prompts fail terribly. I've seen people tweak quotes and then radically different responses. I've seen models just have strange blind spots where no matter how you ask it to do a thing, it just can't do it. So the first observation is just reading something with a prompt, it doesn't work. So we need something more, right? And then if you try a single test, you still run into the same problem, especially in the linguistic space. Broken record here, but different domains, different tones can have very different results. Your language support, all over the place. It may work English to Spanish, English to Turkish, complete failure. Non-linguistic content also has problems. If you have content with a macro that looks like a macro that a prompt wants to use tags, white space can be extremely important. All those things can send the prompt off in directions you don't want it to be. And we also use masked content quite a bit. You have foo objects in a cart. Sometimes that can confuse it as well. And even if you have the most robust tests in the planet, you're still going to have some problems. Temperature, by its definition, causes variance. That's what you want. You want to have different syntax over kind of semantically similar things. Seed, which I can talk about in a little bit, is the idea of making a prompt reproducible by giving it a number that this random number generator will use to execute all choices in the thing. So if you give it the same number, it'll make all the same choices, but those aren't always available. And sometimes it just doesn't work. And there are certain internal model architectures and support codes that lead to really non-deterministic things. So just because something works today doesn't mean it'll work tomorrow or even like an hour. So how do we kind of like, as an engineer, look at this, kind of deal with this environment? And for us, and some of this is going to sound very similar to some of the prior talks, some of our most successful techniques that we've had so far, and most of the models we use are non-reasoning. They're current generation or a generation back. Few shopped examples. So translation memory for us has been a massive win. Translation memory has stylistic choices, formality, it has a terminology. All these things are kind of embedded in your TM. So if you have a high quality TM with high quality examples, it can lead the prompts where you want it to be, way less hallucinations, way less everything. You can get that stuff what you need. Context is key. So ask yourselves, does the prompt have the information to do the task? Because what I wrote here sounds a little rhetorical, right? Like, if a human can't perform the task without the data, can an AI? And sometimes the answer is yes. AIs have a lot of domain knowledge across the internet, so sometimes they can resolve these things. But a lot of the time, if a human needs a point of information, the prompt would probably need a similar blurb of information to do it. So things like document structures that people have been talking about are super important to really give the prompting what you need. And separating structured user input from system instructions can be extremely helpful. A lot of people, especially in the beginning, would put information directly into a system prompt, just embed it plain text in the middle. This can cause all types of problems with sometimes the output stuff. Also, if it isn't structured, can cause some parsing, or if you need to evaluate later what the prompt did, other things. It helps with bad faith inputs that we can talk about a little bit later. And again, non-linguistic content is super important in a lot of use cases, so you don't want this stuff to kind of break your stuff. So you're an engineer, you have all this information, you want to solve these tasks, you have this test, and more test. Again, a ton of other talks at the conference has been talking about testing, evaluation, and doing all these things. And a robust testing system is really the way you want to go. Having a KPI that you can automatically evaluate is super key. Again, categorical and numeric data, you can kind of just have supervised learning type stuff, compare what the results you want. But when you get into linguistics, again, you're in the kind of fuzzy realm and you have all the classic ways of approaching things. Again, we talked about that a lot, so I don't need to go into really a lot of depth here. Again, and sometimes prompts, change. Like I haven't seen a prompt that hasn't been filled with for multiple times over months in my career. Like you're always getting new information, feedback, tweaking things, et cetera, et cetera. And sometimes you generate a prompt that doesn't work as well as a previous prompt. So you need to be able to see previous prompts, evaluate previous prompts, compare it to your current prompt, and make sure you're always heading in this kind of upward direction. And like any other engineering task, you find something that looks like a bug, add it as a test, keep this kind of ball rolling because you don't want to get into like a whack-a-mole situation where fixing one prompt breaks something that was previously working with no regression, and then you fix that regression, and so on and so forth. So having a robust test suite is important. And then also apply engineering best practices to prompts like anything else, right? Evaluation-driven development. Try to figure out how you can be proactive with your prompts. Like, how do you know where it's working in production? What's this outside of research? How do you get the information you need? How can you share that with stakeholders? Kind of think about that type of thing. Version control, again, knowing the history of prompts, knowing when they're deployed, knowing what was applied to what is super important for debugging in the future and really important of kind of, again, marching forward, making these things reproducible. And again, the more language is varied. So the more varied your language, your data set is for testing, the better. Obviously, you have to balance that with cost and other things, like having a 100,000 TU data set's going to cause you problems, but you can find a good kind of middle ground there. For reproducibility and non-deterministics, temperature and seed always kind of come up. Temperature is the idea of you don't use the most probable tokens. You go down a little bit and use still probable tokens, but not the most apparent stuff. This gives it a little bit more of a creative feel, a more kind of active kind of feel to it. And while you can reduce variability by reducing your temperature down, honestly, you should do an experiment with your temperature to see what produces the best response for your particular use case, right? I wouldn't overly worry about minimizing temperature to minimize variability. I would kind of actually lean into a little bit. Seed, on the other hand, is again the concept of having a number that you can give into your prompt via an API during inference that should every single time you give the same number but the same prompt, you should always return the same thing. Some models support this, a lot of models don't. I know there's been kind of a push to try to get it, but it's actually kind of a surprisingly hard problem for LLM engineers to kind of figure this out. So if it's available, please use it, log it, like record what you're doing. But if it's not, then you can move on with other stuff. Again, there's tons of other side considerations that are a little bit hard to get into in a very small talk. But harmful content detection, definitely your friend if you have things on the internet. But if you're doing medical or certain types of entertainment content, it can go off a lot, and then you have to again try to figure out how to balance that off. LLMs have biases like anything else. So again, doctor in English doesn't have a gendered form, but in Spanish it does. So you have to still figure out how to kind of deal with those types of use cases in a kind of a same way to eliminate biases in our things. Batching, super good for cost. It can improve quality. More of a document you're translating, the better. And that can have some very large impacts on the prompt performance. So keep that in mind when you're doing these kind of mechanical changes of how the prompt performs, that you may have to actually do prompt work as well. Don't expect your hosted LLM to be around in 2 years. Like the stuff we were doing 2 years ago, a lot of those things just don't exist anymore or on their way out. So like in 2 years from now, you're going to have the same thing. So definitely think of ways to iterate. In my experience, we almost move forward every 6 months or so to better models and doing other things. And the other thing to keep in mind is AI errors and human errors tend to fall into different categories. So if you're doing a demo or other things, it can sometimes get a little weird when the AI is doing something that's obvious to a human that it shouldn't be doing. but then it's not making the same mistakes as humans. Like they don't generally do spelling errors. They tend to be more grammatically correct, but sometimes it just does things that are strange. So when you're up and running, you've engineered this thing, it's going to prod. You consider that sometimes things are just not going to work with your prompt. Like, how do you catch it and how do you solve for it in a production environment, right? So mechanically, there are easy, trivial tricks you can do. If you're doing English to Spanish translation, you have 100 characters in English, and then you end up with 10 characters in Spanish or 1,000 characters in Spanish. It's gone off the rails. It's pretty safe to like throw that up. And there's a number of other tricks you can kind of do there. It's usually fast, easy, costs almost nothing, but it is language specific, and I think everybody here who's worked in natural language knows there's always an exception to these types of rules. So you have to keep that stuff in mind. Semantic similarity with cosine, another kind of easy trick in the translation space. You can calculate an embedding for the source, calculate an embedding for the translation, look at the cosine, and then get a number of how well it's working. And then for, say, a locale pair, what you do is just get 100 good translations, build a cluster, shuffle the translations. Now you have 100 bad translations, and you can kind of figure out a number above this threshold is kind of good, below this threshold is kind of bad. And that'll give you a pretty easy way, again, to catch the more egregious types of things. It doesn't work on subtle hallucinations, but it does work on like more larger types of errors. Log probability is kind of an interesting trick if your model supports it. Of log probability is kind of the probability of confidence in the tokens itself that the LLM is exporting. So you can kind of look at this to see if the model's struggling with the task or if it's actually kind of performing well with the task. If it's struggling with the task, then you can do things like maybe send it to a larger model or do other things to kind of get an idea of like how to support it. And last but not least, and kind of a popular one today is LLM as a judge. It's great because you can check safety issues. You can check almost any kind of linguistic thing. Just have an LLM. The main problem with LLMs as a judge, though, is quality is kind of bounded in cost and latency or not, right? Like 3 judges may be better than 1, but 10 judges probably aren't super better than 3. Than 100 judges, you're not getting anything except burning money, right? So trying to find out that balance of what you want to look for, what you're trying to evaluate, and the proper amount of stuff in production. And once you found a validation failure, again, there's various ways in production to handle this. Some errors are transient. You get a timeout. You get a rate limit. You're hitting some kind of quota thing. You can try again in the future. That's great. Do not recommend usually hitting the same prompt on the same model if it isn't these types of errors. It just doesn't work. Trying a different prompt or model, again, a fallback mechanism. Okay, I tried against this model. I tried against this other model. Great. Again, quality is bound in cost and latency or not. Some people talk about things like self-healing loops and other things, which are great ideas. But again, you can get into some deep things with the stuff. Obviously, you can just return the failed results. There are some circumstances where that's okay, but generally, these type of hallucinations can be very nasty and just not user appropriate at all. So we don't recommend this case. And again, there's always, if you're in a robust system, to just do a more of a traditional thing, send it to a human, send to NMT, do some other mechanism to translate it if you really need to. Observability. So the other main thing in production is you need to understand what's going on, right? So retaining logs and events of what the prompt's doing is super important when you get errors or other things in the future to kind of come back and really evaluate what's going on. You should always know what the prompt looked like when it's executing, what the data looked like, all that other stuff moving forward. Reports, segment level errors, so you can fix specific thing, locale, pair level, calculate your quality KPIs. A/B testing is useful. Just remember to end your A/B tests. Alerts and dashboards if you can create it to give stakeholders so they can actually see what's going on over time. And another thing I always want to mention in these types of stuff is security. Prompt injection attacks are a real thing. Lots of people enjoy going and trying to jailbreak prompts and see what's happened. If you don't have a prompt that's just sitting on the internet, it's not as big of a deal. But just these are things to keep in mind. Like if somebody can do a prompt injecting attack against any model, then they can potentially have the LLM do whatever they want, right? In which case they can burn through your credits. They can, if you have a fine-tuned model, they can potentially recover things they use to train it, right? Which can be a really big deal in certain circumstances and not a big deal in others. So keep that in mind. And again, if you have an AI hooked up to agentic functions, their prompt injection attack could potentially trigger those functions. So if you give AI the ability to create a Zendesk ticket or a Jira ticket, something could have a a lot of fun, and you won't have a lot of fun when they can create hundreds of tickets, right? So just kind of keep this kind of things in mind when you're doing this type of stuff.
Just want to keep the time in mind, Ben. We're about 5 minutes away of wrapping yours up, so maybe another 2 minutes and then 3 minutes for questions. How does that sound?
Sounds perfect. Great. Thank you. Yeah. And then the longer term considerations always is, at the end of the day, you're trying to develop stuff for humans. So having humans in the loop in some way, shape, or form is great. If you already have post editors or other linguists who are looking at prompts, the result of prompts, or you have access to them to generate little data sets just to make sure you're on the right track. Great. Again, there's other evaluation techniques, but really, at the end of the day, I still really like humans. And again, if you don't actually have linguists, you can just sample data over time. And again, for anything here with like engineering, and one thing that I know people talk about a lot is really trying to figure out what the ROI goal for whatever you're building is for your customers, and then measuring that over time so management and other stakeholders can make sure that's going right. Cost per word, super relevant for a lot of things we do, right? You don't want that to be super high. How often do the validation errors go off? How much time is it taking? Some things people want to happen really fast. Some things people are fine with human speed, so a few days, so which is fine. And again, trying to figure out how to do human quality evaluation with some type of KPI. Yeah, and that's pretty much it for me.
All right, let's dive into some questions. Nicolas Jadot writes, version control. How do you easily navigate between various versions of prompts, and what's the difference between them to make it easier when you have lots of versions?
Yeah, so we have specific tooling internally that we use to kind of track versions. So pretty much every time we update a prompt, there's a version number in the prompt. When it goes to production, we have a little database that we keep around for a little bit so we can examine them. And that version is embedded into every single one of these little events. So we have the ability to match the exact prompt, the exact input, and what happened over time. Just so if somebody is like, hey, this thing broke, 3 weeks ago, what's going on? We actually have in our logs the ability to actually see every single transformation made by a prompt, all the output, and the exact thing that went in. And then we can use that to, create a Jira ticket, have somebody on data science examine the prompt, see if we can fix it, and then do the standard deployment loop.
Okay. Silvio Piccini is asking to elaborate a little bit on AI errors and human errors.
Yeah. So for example, say you're making a prompt that evaluates if a translation is fit for purpose or not. So it's like a quality thing. So it's yay, fit for purpose, boo, not fit for purpose. So generally you would want to have a bias in one of those two directions, right? Is it better for things that are fit for purpose to be ranked as not fit for purpose, or is it better for things that are not fit for purpose labeled as fit for purpose? So you kind of want to determine that bias, because sometimes thinking something is high quality and then doing certain things with it, like minimizing the number of humans looking at it, for example, can have some serious quality problems. So what would happen is you would want to say, okay, it's better for fit for purpose strings to be in the not fit for purpose. But if you have, say, a sales demo, when you're looking at all these things that are not fit for purpose, a lot of the times you're going to be looking at me like, that's obviously correct. That's obviously correct. That's obviously correct. Like, so a human looking at it immediately is like, oh, these are kind of wrong. But due to safety reasons, you kind of biased it in that direction. And that can cause these type of weird things of like makes demos can be kind of a little weird, and some other kind of things like that can be kind of strange. And the opposite direction is true. Like you almost never see a spelling mistake from an LLM, maybe like transliteration or something like that. But generally, those types of like typos, LLMs don't generally make. So it kind of goes in both directions. So the distribution of errors.
Yeah. One last one from Marco Russo at Creative Words. Does it make sense to use translation quality evaluation to tell human post editors which AI translated segments require more attention?
I mean, yes.
That's a quick answer. Do you want to elaborate on that? I know Gabriel is stomping his feet in the background, so we're ready to switch it out. Maybe this is a good time.
Yeah. I'll just leave it at yes.
All right, good. Thank you so very much,
Thank you,
Benjamin.
everybody.
Fascinating.